And welcome to another revision video for the Edexcel Core 3 Maths A-Level syllabus. In this video we will work through all the past paper questions that have come up on function transformations and involving modulus transformations as well. I know this is a tricky topic for a lot of people, so I just thought I'd take a minute at the start just to review the different transformations. I'm not going to explain why they work. That was part of your learning. I'm just going to remind you of what they do. The first four ones, the basic four ones you should know. I have drawn a function f of x here and we're going to just transform it in various ways. The first one you should know, f of x is transformed to f of x plus a. What is that? Well, that is a translation of a units in the positive y direction. What about f of x to f of x plus a, where x plus a is in brackets? Well, that's a translation, but by a units in the negative x direction. What about this one? This is a stretch by factor of a in the y direction, and this one, when it's inside the brackets, everything's a bit strange. When it's inside the brackets, it's a stretch by a factor of 1 over a in the x direction. So, for our function here that I've drawn, I'm going to let a be 2. And I'm going to try and draw each graph. If this is f of x, what does, for part 1, f of x plus 2 look like? Well, it is exactly this graph, but it is translated a units in the positive y direction. So if that was the original graph, it would go up 1 unit and 2 units. And so I could label all the points this point here would therefore be, if this was negative 4, 4, this would now be negative 4, 6. This here was negative, was 0, 4, so where it crosses the axis here would be 0, 6. And this one here, we don't know where this root would actually end up being. We know where this would be. This would be negative 2, 3. We don't actually know where this root would be anymore, but we could work it out by just solving a simple equation, but we don't know where that root is as yet. Okay, that's that one done. I'm going to do each one part by part. Okay, what happens if we translate it, if a was 2 and we do the second transformation? So a is 2 and we do the second transformation. So we're working out f of x plus 2. Well, again, let's just copy this here. And we say it goes 2 units in the negative x direction. So 1 unit, 2 units. And we could label each of these points. This point here would clearly be negative 6, 4. This point here would be negative 7, 0. This point here would be negative 4, 1. And we no longer actually know where this point is. We'd have to find it using algebra. Okay. Next. A is 2. Let's do the third transformation. We would work out f of 2 f of x. Now this one I'm going to have to draw. At this point here, y is 0. So if we double it, it still stays at 0. So that stays where it is. Here, the y number doubles, so it would be negative 4, 8. This point here would be negative 2. 2 would double, the y value would double, so it would be negative 2, 2. This point here would be negative, would be 0, 8. So it would actually end up looking something like this. Okay? A stretch by scale factor 2 in the y direction. All the y values, for a particular x, the y value is doubled. Obviously, where y is 0, it stays where it is. So that's what that would look like. So we've done the third one. Now let's do the fourth one. So we're going to work out f of 2x. Okay, for these ones, all the x values are halved effectively. For a particular y, the x values are halved. So when y is 0, this is now 2/5. It would be somewhere here. Sorry, -5/2, 0. This point here, for that y is 4, this would now be -2. So it would be somewhere like here. This would now be -1, 1. So it would be somewhere like here. This one here, for the y is 4, if you halve 0, you still get 0. So we can see that our graph is sort of shrunk by a factor of 2. It looks something like that. And there we go, we've done the 4 basic transformations. What points are these? That's -5/2, 0. This point here would be -2, 4. This point here would be -1, 1. Okay, so we should be able to label all those points. Okay, they are the basic 4 transformations. Let's move on to reflections that we need to know as well. If f of x goes to negative f of x, what's that? Well, that's a reflection in the x-axis. And how would this one look if we reflected it in the x-axis? So if we were to draw negative f of x, everything we see, we reflect it in the x-axis. So this here reflected would be like so. Something like that. Those points would be in common. That point there would be -2, -1. That point there would be 0, -4. This point here would be -4, -4. Okay, so it's a reflection in the x-axis. That was easy. So what about if we drew now f of negative x? What is that transformation? Well, you should know that's a reflection in the y-axis. So it would look something like this. It would reflect in the y-axis as follows. Okay, that point there would be the same. This point here would now be 2, 1. This point here would be 4, 4. And this point here would be 5, 0. And it's as simple as that. Okay, so we've done a lot of transformations. Now it's time for combining transformations. What if you were doing something like a stretch and a translation in one go? What happens here? Well, imagine you were transforming f of x to a f of x plus b. The stretch is outside the brackets, and the b, the translation, is inside. When there is one outside and one inside, the order in which you do it doesn't matter. If you were going for f of x to f of ax plus b, here's a stretch by 1/a and a translation by b in the y direction. Does it matter which order we do it in? Well, one's in and one's out, order doesn't matter. What about f of x to a f of x plus b? Here there's some sort of stretch by scale factor a in the y direction and a translation by b in the y direction. They're both in the y direction. So the order in which you do it does matter, because if you, for example, if you were to translate first and then stretch, then you are moving the translation. You're moving the translation, you're stretching it after you've done it. So this one, actually, when they are both outside, it's telling you, do the stretch first and then do the translation. This one, you have a stretch by 1/a and you've got a translation by b in the negative x direction. They're both in the x direction. Order does matter. When they're both inside, you do the b first, then the a. I'm not going into the rationale behind this, but that's how it works. So, for example, if we let's say, I don't know, a be 2 and b be something like 3, what would each of these be? What would a should be 2 and b should be 3? What would 2 f of x plus 3 look like? Well, the order in which you do it doesn't matter. So everything is getting stretched by a scale factor of 2 and then shifted by 3 units in that direction. Or you could shift it by 3 units and then do the stretch. Because one's in the y direction, one's in the x, they don't affect each other. I'm not going to go explicitly over all these coordinates here. Similarly, if it was f of 2x plus 3, then what you can do is you can squash all these by a factor of 2, and then you can shift it in the y direction. However, If you were considering 2f of x plus 3, then you must do the transformation, the stretch by 2 first. You must stretch it by 2 first and then shift it by 3 units because they're both in the same direction. And what about if it was f of 2x plus 3? Then you must do the translation by 3 units in the negative x direction and then a squash. So the order is important when one's in and one's outside. Okay, last transformations to think about are the modulus ones. Here's our graph f of x. What does mod f of x look like, modulus of f of x? Well, how you do it, you draw f of x, which I've done. You reflect anything negative in the y-axis. So here we're positive, 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 positive. Start getting negative, you reflect it like that. And that would be mod f of x. Then you would cross out this here. And it would be as simple as that. So basically mod f of x just draws the f of x graph, and where f of x is negative, it makes it positive. What about f of x to f of mod x? Well, you draw f of x for x positive, so I draw f of x for x positive here. Ignore anything where x is negative, so all these good points here get ignored. Reflect everything you've drawn in the y-axis, so it would look something like this there. And you would cross out here because you didn't even need it at all. And that would be your f of mod x graph. Okay, now I think we've covered all the transformations here and we're ready to do the questions. As always, pause the video, attempt the question, then work through my solutions and mark your work. Okay, question 1. Okay, let's go through these. As always, they give you a graph, they tell you some points on the graph, which they've written here, and they ask you to draw the following. Okay, let's do part 1. Now, this graph here, there's 2 things going on. There's a reflection and there is some sort of translation in the y direction. One's inside, one's outside. Order doesn't matter. So what you can do is you can reflect this first and then you can shift it up by 1 unit. So f of negative x, what does that do? Well, it reflects in the y-axis. So it would end up looking something like this. The first stage, if you were to draw f of negative x for the first stage, it would look something like this. With that point there is negative 2, 3, and that point there is still 1. Okay, and then if you were to draw a translation by 1, then it would look something like this. It would be up a bit more and then cross here. So that point there would now be 2, and that point would be negative 2, 4. And we've done the first part. Okay, next part. We're asked to draw this graph. Okay, so one's inside, one's out, so order doesn't matter. So I might just draw each one separately. So if I was to draw the graph of, let's say, f of x plus 2, f of x plus 2, that is a shift by 2 units in the negative direction. So it would look something, this point here would there be shifted to the top. So it would be something like this. Now that point there would now be the point 0, 3. And this point here, this point here has been shifted over here. Now we're not told anything about this point and this point, so all I can do in that first part is label that point. Then I want to move it up by 3 units. So then I want to do a shift in the y direction up by 3 units. So if I was then working out f of x plus 2 plus 3, then this would be shifted up as so. And that point there would now be 0, 6. And that's the only point I can deal with. Okay, next, part 3. We've got some sort of stretch in the y direction and a stretch in the x direction. One's inside, one's out, so you can do them separately. Okay, so let's go about by drawing. Let's say draw, I don't know, 2f of x first. Let's not worry about the inside stretch. So this here, you double everything, you double all the y values, so that there would now be the point 2, and this here would now be the coordinate 2, 6. And then, so I've done that part of it, now I need to do that part, and remember, order didn't matter, that's why I chose it in any way I wanted. Now, this is a stretch by 1 over 2 in the x direction, or a squash by factor 2. So this is going to be more squashed. This point's not going to change here because it's at x is 0. That can't be squashed. But this point here now would be, and that would be the point 1, 6 now. And I'm done. Okay, next question. Pause the video, have a go. Okay, it asks us to express this as a simplest fraction. So f of x is equal to 2x plus 5 over x plus 3 subtract 1 over x plus 3 x plus 2. Now what I could do actually, if I want to add these fractions, what I should do is make the denominators the same. They've both got an x plus 3, that's good. But this one has an x plus 2 as well, so I can multiply the top and bottom of the first one by x plus 2. Okay, and then I would get myself, if I multiply this out here, I would get 2x squared plus 9x plus 10, subtract 1, all divided by x plus 3x plus 2, which is 2x squared plus 9x plus 9 over x plus 3 x plus 2. Is there any way I could factorise the top? Well, I could write that as 2x and x. If I had, let's say, plus 3 here and plus 3 here, that would be the perfect factorisation. X plus 2. You'll notice they now have a common factor of x plus 3 on top. So actually, this is, as a simple fraction, 2x plus 3 over x plus 2. And I've done for 5 marks. Next part. Hence show that f of x is equal to this. Well, we've just shown that f of x is equal to 2x plus 3 over x plus 2. 2x plus 3 over x plus 2. Well, how could I show that f of x is also equal to this? Well, there's a way of doing it algebraically, which I'll do that down the side. But what you could do is, if you assume that f of x is 2 subtract 1 over x plus 2, and you try to work with this, so times in top and bottom by x plus 2, and then expanding out, so 2x plus 4 subtract 1 over x plus 2, and hence I get 2x plus 3 over x plus 2. Now, I've worked with this, what I've done is I've assumed that's true, I've played around with it, and I've got 2x plus 3 over x plus 2. Hence, they're the same. That's probably the easiest way of doing it. There is another algebraic step to go from here to here, but it's probably not needed to go through. Then it says the curve y is 1 over x, where x is bigger than 0, is mapped onto the curve y is f of x using 3 successive transformations, t1, t2, and t3. T1 and T2 are translations. Describe fully T1, T2, and T3. So, y, to start with, is going to be, I'm going to call it g of x, and it's equal to 1 over x. Now, what is f of x equal to? F of x is equal to 2 subtract 1 over x plus 2. So, f of x is equal to 2 subtract 1 over x plus 2. Okay, how do I get from the 1 over x graph to this graph here? Via transformations. Well, the first one, t1, I'm told that is a translation. So why don't I let t1, so t1 is the translation 2 units in negative x direction. I.e., we're working out g of x plus 2. And g of x plus 2 would be 1 over x plus 2. So that gets us part of what we're looking for. But then there's other stuff to do. Now, what does T2 do? T2, what could we do now with this function here to get it looking like that? Well, what if we did a reflection in the x-axis? So actually we're making g of x plus 2 negative. So we get negative 1 over x plus 2, which gives us this negative sign as well, which we want. And then, lastly, what if we did, how do we get T3 then? Well, we add 2 to this, so it would be 2 units in positive y direction. So it'd be like adding 2, so we'd be doing 2, subtract g of x plus 2, we'd be adding 2, which would give us the 2 subtract 1 over x plus 2 we're looking for. So here's our first, T1 must be that, T2 must be that, and T3 must be equal to that. Next question, pause the video, have a go. Okay, draw the graph of ln of mod x. Now, what's the graph of ln x like? Ln x just looks something like this, and that point there is the point 0, 1. That's the graph of y is equal to ln x. In this case, our f of x is equal to ln of x. Now, what if I wanted to draw the graph f of the modulus of x? You'll remember from the start how you do that. Well, what you do is you draw the graph for all x positive, and then what you do is you reflect that in the y-axis. Now, I've just drawn this for all positive, so this is what it is. I'm actually going to shrink it down because I realise I'm going to have to do a reflection now. So you've drawn the graph for all positive, and then you reflect that in this axis, so it would look something like this here. A perfect reflection that should be, and that should be, so that should have been 1, 0, my fault, and this should be negative 1, 0. And that is the graph of y is the modulus, ln the modulus of x. Okay, next, pause the video, have a go. Okay, we're given a function, we're told some key points here, and we're asked to draw the following. Now, for part A, there are 2 transformations going on here. There's some sort of stretch in the y direction and there's some sort of translation in the y direction. They are both outside the brackets, and I said that when they're both outside, you do this one first and then this one. So let's draw ourselves some axes and let's do the doubling first. So this one here would double up here and come down here and be double over here. So that point there would be the point 3, 10, and this point here would be the point 7, 4. This is a stretch by 2 in the y direction, and that would be equal to 2 f of x. Now we want to, afterwards, having done that, we want to do a translation by 4 units, a negative 4 units in the y direction. So everything will be pulled down by 4 units. So it would still come up like this. However, this point here would now be 3, 6, and this point here would now be 7, 0. And that would be 2 f of x subtract 4. Okay, next one. What would the modulus of this graph look like? Well, remember I said how to do these ones. You first of all draw the original graph, and you keep everything where the y number's positive, but where the y number's negative, you reflect it in the x-axis. So it would look something like that. So if I was to draw it separately, I would draw it looking something like this. It would come down like this, up, share all those points, go down to there, and then it would shoot off in that direction. This point here would still be 3, 5, and this point here would still be 7, 2, and this was the modulus of f of x. And we're done. Next question, pause the video, have a go. Okay, we're told various key points on the graph here. We are asked to draw f of x plus 3. That is, you should be aware of this, this is a translation by 3 units in the positive y direction. So this graph would then look something like this. That point there would now be 2, 7. That's part A done. The modulus graph, draw f of x but mod f of x. What you do is you draw the graph out. That would still be 2, 4. But where the y number is negative, you now reflect it in the x-axis, so it would come up here as such. So that would be the modulus of f of x. And that's done. And the next one, you're drawing f of mod x. So you draw your graph for this transformation, draw your graph out. And I said draw it for everything where x is positive. So draw it for all this branch here. So you draw that out as such, and that would still be 2, 4. And you reflect everything you see in the y-axis. So reflect it in the y-axis, and that therefore would be the point negative 2, 4, and you're done. Next question, pause the video, have a go. Okay, firstly we're going to draw the modulus of this graph. So you draw the graph out. We're going to draw modulus f of x. Okay, you draw the graph out. And then what I said is where y is negative, you reflect that in the x-axis. So it would look something a bit like this. You'd rub out this part here. Well, you know that's at minus 4, minus 5. Sorry, minus 5, minus 4. So this point here would be at minus 5, 4. And this point stays where it is at 5, 4. And we're done for that. Part B, we're now drawing f of mod x. So we're drawing f of mod x. Now remember I said draw the graph for where x is positive, so draw all this stuff here. That should be 5, 4. And then just reflect it in the y-axis, so it would look something like this. And that obviously therefore would be negative 5, 4. And we're done. Next one. Well, here we've got some sort of stretch by 2 units, stretch by factor 2 in the y direction, and a translation by negative 1 units in the x direction. One's inside, one's outside, so the order does not matter in which you do it. So to start off with, I might do the let's do the stretch first. So this point here would go down. This point here would there go. Stretch by factor 2 would be negative 4, negative 5, negative 8, and this one here would be 5, 8. And then you would do a translation by negative 1 units in the x direction. So this was 2f of x. So if I draw, maybe if I just shift this over here. So what would the next one look like? I'll draw it a bit smaller maybe. This would be shifted over 1 unit in the x direction. So this point here would now be negative 6, negative 8. It would go up through this point here. And this point here would be 4, 8. This point here would be, we don't know the x value of that point, but we know this point here has been shifted 1 unit in that direction, and we're done. Okay, next question. Pause the video, have a go. Okay, for the first part, here's our curve, and we're doing a translation by 1 unit in the negative x direction. So for the first part, it's going to be nice and straightforward. Everything's getting shifted 1 unit in that direction. So it looks something like this. This point here would therefore be 1/3 1. This point here would therefore be -1 0. And this point here would therefore be 1 0. And that's we're done. Next part, part B, we're asked to draw the modulus of this graph, the modulus of f of x. So what you do is you draw the graph f of x, and wherever f of x became negative, you just reflect that in the x-axis, as so. Rub out this part here and write in all your key points. That's still 4/3 1, that's still 0 0. This point here is still 2 0, and we're done. Do bear in mind here, you're not allowed to have that looking like a U. It's got to look kind of like that because of the way the graph works. If you have a U, it doesn't give you the mark. Next question, f of mod x. Well, what you do for this, you draw out the f of x graph where x is positive. There. And then you reflect it in the x-axis. So you're going to reflect this in the x-axis as follows. So that point there would be -4/3 1. This point here would be -2 0. And the points you had previously, that's obviously 0 0. This point here would be 4/3 1. And this point here would be 2 0. And we've marked all turning points and where it met the axis. They are our 10 marks. Next question, pause the video, have a go. Okay, first of all, we're drawing the modulus graph of this. So we draw our axes. I say always draw f of x. F of x looks something like this. But where f of x becomes negative, you reflect this at this point up. So it would be reflected like that. Remember, it shouldn't be a U shape, it should be some sort of cusp shape. And this point here would therefore be 0 2. This point here would still be 1 0. And over here would still be 4 0. So that's that done. Okay, next one. We're drawing f of 2x. Now remember, the 2 is inside the bracket, so this is a stretch by 1/2 in the x direction. So all the x values get squashed by half. So the y values aren't so concerned. That stays where it is because x is 0. If you squash it by half, it's still 0. However, that there would now become a half 0. Be something that looks like that. Okay, and we're done. And the last one is draw the inverse graph. Now you should know the inverse graph is a reflection in the line y is equal to x of this. So you know it's going to look something like this, something like that. So let's draw it out as neatly as we can. You know that the point 1 0 is now going to be here. That's going to be the point 0 1. You also know this point here, 0 -2, is going to be here at -2 0. And you know 4 0 is going to be up here at 0 4. Okay, so here's the original graph. Let's try and draw the original. It looks like that. Here's the line y is equal to x, something like that. And f to the -1 should look something like this. So that would be f to the -1 of x. And we're done. Next question, pause the video, have a go. Okay, first part, we're asked to draw the modulus graph. Now we should be getting familiar with these. You just draw the graph as you see it. And you reflect everything you see in everything that's negative in the y-axis. So it would end up coming up like this and then going through here, something like that. So you'd rub out this part here. This point's a key point, 3, 0. It must look like a cusp rather than a U. And this point here would now be 0, 2, and you'd be done. Next part, draw the inverse graph. Well, it's a reflection in the line y is x. You know it's going to be a reflection in that line. So let's try and draw it out. You know that this point here, 0, negative 2, would now be an important point on this graph, negative 2, 0. X and y rolls a swap. And 3, 0 would be an important point in this graph. It would be up here at 0, 3. You know the graph looks something like this. That would be the line y is equal to x. So reflecting it, it must look something as follows. Something like that, a reflection in the line y is x. So this would be f to the minus 1 of x. Okay, next part. We have got some sort of stretch by scale factor of third in the x direction, and then we've got some sort of stretch by factor half in the y direction. One transformation's inside, one's outside. Order does not matter. So we're going to draw two graphs. The first graph we're going to draw is, let's draw a half f of x. That's a stretch by a factor of half in the y direction. So this point here would now be 0, negative 1. This point here would still be 3, 0, and it would look something like this. And then we're going to draw the half f of 3x. This, therefore, is going to take this graph and it's going to stretch it by a third in the x direction. Okay, now this point would stay the same, so this would be 0, negative 1. But this point will be squashed in by a factor of 3, so it would actually be at 1, 0. And it would look something like this then. And we'd be done. Next question, pause the video, have a go. Okay, part A. We are asked, here's a curve, we're given various points on the curve. We're asked to write down the coordinates of the point to which A is transformed if this was the equation. Now mod f of x, remember what mod f of x looks like. You draw f of x, but where it goes negative, you make it positive. Okay, so write down the coordinates where A is transformed to. A would therefore be moved to 3, 4, 3, positive 4, simple as that. Okay? Next part, where would A be moved to after that transformation? That's part 1. What about part 2? Now remember, there is a stretch in the y direction by 2, and then there is a stretch by 1 over half by 2 in the x direction. One is inside, one is outside, order doesn't matter. So here, in any order we've got here, this is giving us, actually I'll write 2 here, this is a stretch by 2 in y direction, and is a stretch by 1 over a half, which is also 2 in x direction. Okay, so therefore where does 3, 4 go to? Well, 3, 4, in the x direction this gets stretched by 2, so it would go to 6, and this gets stretched by 2, so it would go to negative 8. So A would go to 6, negative 8. Okay, next part. Sketch the curve with the equation f of modulus x. So f of x, let's just actually copy that, so we've got a picture of it here. That's f of x. How do we draw f of modulus x? Well, what you do, I'm going to draw out an axis. You draw everything where x was positive, x was a positive value. So that point there is 0, 5. This point there is 3, negative 4. And you reflect it in the y-axis. So you would just reflect this down there. It would look something like that. That point there would clearly be negative 3, negative 4 then. And you'd be done for 3 marks. Next question. The curve with equation y is f of x is a translation of the curve y is x squared. Find f of x. So y is x squared, that's what we've got. And what is f of x? F of x is this graph here. So let's pull that graph over. That's f of x there. Now it tells us that this curve is simply a translation of this curve. It's simply moved in some way. How is it moved? Well, because you know the minimum is 3, negative 4, and normally of an x squared graph it's 0, 0, what you've done is you have moved this graph by simply translation. It says there's no stretch or anything. You must have moved it 3 units in that direction and negative 4 units in that direction. So if I was having to state the translation would be it is a translation 3 units in positive x and a translation negative 3 units in y direction. Okay, so what does f of x look like? Well, it's the x squared graph. It's x squared graph, but we have shifted it 3 units to the right, so it would be x minus 3 squared. And then we have, after we've done that, we've shifted it down by 4 units. That should have been 4 there. So that was what the graph would look like. Explain why the function does not have an inverse. Why does f not have an inverse? Just looking at f, how come f does not have an inverse? Well, the only functions that have an inverse are 1 to 1. This function, there are many x's that give the same y, so it is a many to 1 mapping. Therefore, no inverse. And it's as simple as that. Next question, pause the video, have a go. Okay, for part A, it asks us to draw the modulus of this graph. I'm just actually going to draw it in a red pen on here. The modulus of this graph, you draw everything of f of x, and where f of x becomes negative, you reflect it. This was negative, so you reflect it. So this point here, that point is the point as it always was. This should not have touched the axis. It's not supposed to have touched the axis. It's supposed to look like that. This point here would therefore be 0.4, positive 4. And this tip here, this was supposed to be a tip here. This tip here would therefore be negative 0.5 and positive 2 because it's a reflection. And I'm done. For part B, we're asked to draw this graph f of x minus 3. That is a translation 3 units in positive x direction. So if I'm just going to actually use the original graph to do this. So if I was to shift all of this by 3 units, that would be 1, 2, 3, 1, 2, 3, 1, 2, 3. It's probably actually easiest, it's not working out as I wanted it to, it's probably actually easiest to draw this out again. So if I drew out this graph here, everything's getting shifted by 3 units, so that dotted line there, that asymptote would actually be at 3, and the graph would look something like this. This point here would be 3.4, negative 4. So it'd be something like this. And labelling that would be 3.4, negative 4. That asymptote there, it was at 0, and now so that was at 1 before, so now that's at 4, that's at 3, and then the graph would then look something like this. And that point there, it was at -0.5, but it's been shifted over, so it's going to be at 2.5, -2. And we're done. The last one, it asks us to draw the f of modulus x. So you draw the graph out as it was and you reflect it in the y-axis. So you draw the graph out for positive x even. So for positive x, that's supposed to be a dotted line here. Let's make that dotted to show it's an asymptote. So it did look something like this. Okay, and all we do is, that's x positive, we reflect that in this axis here. So we would reflect that like that, and we would also have another asymptote over here like that, and we're reflecting everything in the y-axis here. So this point here was 0.4, -4. So this point here is -0.4, -4. This here was 1, so this here is -1, and we're done. Next question, pause the video, have a go. Okay, part A, show that there is a root in this interval. What we do is we work out f of -2, we work out f of -1. If there is a change of sign, because this curve is continuous, there must be a root in that interval. So on your calculator, you substitute in -1 and -2. If you put in -2, you get 16. If you put in -1, you get -3. Therefore, you can say change of sign, f is continuous, therefore root in interval -2, -1, and you're done for 3 easy marks. Part B, find the coordinates of the turning points of the graph. A turning point is where the gradient function dy by dx is 0. Now the graph, our function is y is x to the power of 4 minus 4x minus 8. Y is x to the power of 4 minus 4x minus 8. Find the coordinates of the turning point. Let's differentiate. Dy by dx is therefore 4x cubed subtract 4, and you want to solve when this is equal to 0. Okay, you can factorise out of 4 and you get x cubed minus 1 is 0. Divide both sides by 4, you get x cubed minus 1 is 0. And add 1 to both sides, x cubed is 1. Therefore x is the cube root of 1, and for real numbers the only answer is x is equal to 1. What's the corresponding y value? We'll substitute in y, substitute 1 back into the original function here, and you will get y is -11. So the coordinates are 1, -11. Done. Part C, given that f of x can be written in that form, find the values of a, b and c. What this is telling me is that x minus 2 is a factor, or you can say that if you put in 2 into the function, you would get 0 back. Now let's write our function out. F of x is x to the 4 minus 4x minus 8. So the function is x to the 4 minus 4x subtract 8. The way I like to do it is as follows. You're taking a factor of x minus 2 out. What needs to go here to multiply by the x to get the x to the 4? X cubed, obviously. If you do that, you create the x to the 4, what you want, but you create a negative 2x cubed. Now I don't want any x cubes, so I'm going to have to add back 2x cubed to undo this. So what needs to go here to multiply by the x to get 2x cubed? Well, plus 2x squared. When I do that, I get the plus 2x cubed I want, but I also get negative 4x squared. I don't want any 4x squareds. I want no x squareds. So I'm going to have to add back 4x squared. What needs to go here to multiply by this to give me 4x squared? Well, plus 4x. If I do that, I get the 4x squared I'm after, but I get negative 8x. I don't want negative 8x, I want negative 4x. So I need to add back 4x. What needs to go here to multiply by the x to give me 4x? Or plus 4. And while I'm doing that, that then gives me the 4x I want, but it also gives me a minus 8x that I want, and I'm done. Therefore, what is A? A must be 2. What is B? B must be 4. What is C? C must be 4. Next one. Sketch the graph of y is equal to f of x. Now, f of x, our graph was x to the 4 minus 4x minus 8, x to the 4 minus 4x, subtract 8. What do we know? Well, we know a couple of things about it. We know it has a turning point at 1, negative 11. So it has a turning point at 1, negative 11. Anything else we know about it? We know that it factorizes as x subtract 2, x cubed plus 2x squared plus 4x plus 4, so plus 2x squared plus 4x plus 4. Okay, so if we're trying to find where the graph is equal to 0, how could we do that? Well, where is y equal to 0? Well, it's where this is equal to 0. And the only answer we know for sure is that x is 2 is an answer and where that is an answer. But we don't know how to necessarily factorize that as such. We also know that when x is equal to 0, y is equal to negative 8. So we know another point. So let's see if we can put the points on here that we think it might be. We know the graph goes through x is 0, y is negative 8. So let's just actually make that up there. When x is 0, y is negative 8. 0, negative 8. We also know that it has a root at x is 2, i.e. when x is 2, y is 0. So when x is 2, y is equal to 0. The last thing we know is it has a turning point at 1, 11, at negative 11. So it's got a turning point here at 1, negative 11. We know it's a power of 4 graph, so it looks a bit like an x squared, but a bit sort of more square. And I think we've got enough to draw it in now. So we can draw it in as follows. It looks something like that, and we'd be done. Last part, hence sketch the graph of the modulus of f of x. Well, if we had our graph f of x, we had it on the previous page, the modulus of it is just, the graph looks something like this, didn't it? The modulus of it would just be this point reflected here. So I'm going to rub those points out and I'm going to label in the key points here. This point here should be 2, 0. So this point here would be 2, 0. This point here was 1, negative 11. So this point here would be 1, positive 11. This point here is 0, negative 8. So this point here is 0 and positive 8. And we didn't know what this point is, so we don't really care. And we're done. Next question, pause the video, have a go. Okay, it tells us that the figure shows y equals f of x. The curve meets the axis at the point A is 0, 1 minus k. So this point here is 0, 1 subtract k. And at B, which they've given us helpfully in a nice easy form, half ln k, 0. K is bigger than 1. On separate diagrams, sketch the following curves. Well, this is quite easy. For 3 marks, mod f of x, you just draw the f of x graph and where f goes negative, you reflect it. So it's got to look like a cusp, something like that when you do it. So there's 1 mark for getting that right. And this point here would still be, this b here would still be a half ln k0, but this point here would now be 0, and the negative of this, which will be k minus 1. And we'd be done for that. Next, draw this curve. Now this curve is the reflection of this in the line y is equal to x. So just very, basically you can imagine it would look something like this. Okay, so we're going to use that fact here. We know a and b are, this point here is 0, 1 minus k. It's going to come over here, it's going to be a point there. And this point here is a half ln k0, so we're going to have a 0 at half ln k. It's going to look something, as I did above, something like this. Where this point here, this key point here is this point here would be 1 minus k0. That came from the A, and the B point here where it crosses B previously, it crossed that half ln k0. So this point here would be 0 half ln k, with the x and the y roles have swapped. Next part. Given that f of x is this, state the range of f of x. Okay, that's f of x. What's its range? Well, this is like, remember, just normally to the x graph. A normally to the x graph is like that. And its range is, if that was f of x, its range is f of x is bigger than or equal to 0. Now, this is like an e to the x graph, apart from it's e to 2x, which just means it's steeper. But it's been shifted down by k units. Okay, so it's been shifted down this graph by k units here. So where it asymptoted to for y is 0, it now asymptotes with y is negative k. So therefore, the range of f of x is always bigger than k. This here, I made a tiny mistake here. F of x can never equal 0, it's always bigger than 0. And we've been shifted down by k there, so f of x is bigger than k. That's the range. Sorry, bigger than negative k even. Negative k, sorry. Because it's been shifted down by negative k units. Next part, find the inverse function. Well, you could let y equal e to the 2x, subtract k, add k to both sides, y plus k is e to the 2x. We're trying to make x the subject of the formula. Take lns of both sides. Bring down the power of 2x and use the fact that ln e is 1. So we get ln y plus k is equal to 2x. And therefore x must be a half ln y plus k. Therefore we can state the inverse function f to the minus 1 of x is a half x, a half ln of x plus k. Okay, next, write down the domain. Well, here's our function. I can't copy it. F to the minus 1 of x. F to the minus 1 of x is equal to a half ln x plus k. There. The only thing, we can never have ln of 0, so you could never have x is equal to negative k, or you could never have ln of a negative number. So therefore, in the domain of this, x would always have to be strictly bigger than negative k for this to work. And we've done, and we've got our 10 marks. Okay, last question of this series. Here's a diagram. There's f of x. It tells us some key points on the diagram, and it asks us to draw various transformations. Okay, so let's have a go. The first one, the modulus of f of x. Easy. You draw the graph as it is. I'll draw it with straight lines actually. You draw the graph as it is for where x is positive, and then where x is negative, where f of x is positive, and where f of x becomes negative, you reflect this bit up and you reflect this bit up, and you write in your key points. Okay, that point there is still R. That point there is still Q. The point P, does it tell us that's still point P? This point here is still -3 and 0. And we're done. Then it asks us to draw f of -x. Remember what that is? That's simply a reflection in the y-axis. So we draw this out. And you reflect this part in the y-axis, so it would end up coming down here, and you reflect this part in the y-axis, so it would end up coming up here as such. Okay, so this point here now, this point here should be 3, 0, for example. Next, we are told that f of x, we are actually given what function it is, it's actually that, and we're told to find p, q, and r. Okay. I'll do a bit of working up here. Let's find the easy ones. Let's find q first of all. For q, at q, x equals 0. So therefore f of 0 is 2 subtract 0 plus 1. And the modulus of 0 plus 1 is the modulus of 1. And 2 subtract 1 is 1. So that would be 1. Therefore q has coordinates 0 and 1. That's easy. Now, why don't we try and find where, let's say, r is? For r, what's true? Y is equal to 0. Okay, so we would have 0 is equal to 2 subtract the modulus of x plus 1. There are two ways to solve this. There are two different routes. Either you solve the equation 0 is 2 subtract positive x plus 1, or you solve the equation 0 is 2 subtract the negative of x plus 1, the way the modulus works. So 0 would be 2 subtract x subtract 1, 0 would be 1 subtract x, and therefore x would be 1. There's one solution. Or from this one, 0 would be, it would be 2 plus x plus 1, 0 would be 3 plus x, and x would be -3. Now x being -3 when y is 0, that's that answer. You have found r, this must be r. R must be, therefore, 1, 0. Now how then do I go about finding the coordinates of r? P even. How do I find the coordinates of p, which is this point here? Well, this is clearly the maximum of this function. And where does this function have a maximum? Because the modulus of x plus 1, that's always positive. That's always a positive number. We're always subtracting some positive. So at most, f of x could be 2. And the case it could be 2 is when x would be -1, because then that would be -1 plus 1 is 0, and we're subtracting nothing. So p must, just by inspection, because it's the maximum, must have x coordinate -1 and y coordinate 2. And that's it, we're done. Okay, and the last part, part D, solve f of x as a half x. We're solving where this graph is equal to the graph of half x, and the graph of half x looks something like this here. So it's going to have a solution here, and it will have one down here at some point. So, f of x, let's remind ourselves what f of x was. F of x was equal to 2 subtract x plus 1, so 2 subtract the modulus of x plus 1. If we're solving this is equal to half x, there are two things we're going to solve. We are going to solve where 2 subtract the positive of this equals a half x, and we're going to solve where 2 subtract the negative of this equals a half x, just by the definition of modulus. So that would be 2 subtract x subtract 1 is a half x. 1 subtract x is a half x. Add x to both sides. 1 is equal to 3 over 2x. Divide both sides by 3 over 2. X must be 2/3. And that's our x value there. The other one here, this would be 2 plus x plus 1 equals a half x, be 3 plus x equal a half x. Subtract x from both sides, 3 would therefore be negative a half x, and then divide both sides by negative a half, x would therefore be equal to negative 6. And we're done. There's the two solutions for this problem. And they are all the questions on transformations and transformations including modulus in Core 3. Thank you for watching.